Hey guys, welcome back to another Tutor Toby video. Today we'll be going over how to solve first order differential equations using the separation of variables method. So first off, we'll be going over what is an equation that's separable, so how do you determine if an equation is separable, and then second we'll be going over how do you solve these differential equations by separating the variables, whether it be dy over dx or dy over dt. The variables don't really matter, just like how do you solve these differential equations. Okay, so first off, how do we know that an equation is separable? So we know that an equation is separable if we have, for instance, I'll use dy over dx is equal to some function with respect to y times some other function with respect to x. I use f and g here, just because I want to say that these don't have to be the same function. So for instance, my f of y could be equal to y squared plus 1. And my g of x could be equal to square root of x, for instance. Okay, so let's go over some examples of separable equations. So real quick and easy one, let's say that y prime is equal to 1 plus y. So obviously this is separable because we can say f of y is equal to 1 plus y, and we can have g of our differential variable x is just equal to 1. So another example we could think of would be y prime equals natural log of t times y. So this is not separable because we cannot make an f of y times g of x term. Okay, so now for a third example, I'll be using y prime is equal to e to the t plus y all over y plus 1. So when we first look at this, it's pretty complicated differential equation, but it actually is separable. And we can note that because we know that e to the t plus y is actually just equal to e to the t times e to the y, just by addition of power rules. So then we can actually make our f of y equal to e to the y divided by y plus 1. We can make our f of t, or g of t in this instance. We're using the differential variable t instead of x like I used up there, but it's the variable name is completely arbitrary. But we still have g of t is just equal to e to the t. So this actually is separable, and we could get it into the form y plus 1 all over e to the y dy is equal to e to the t dt. And we could actually then solve for this by just slapping on an integral of both sides. But this is a rather difficult integral that I would probably use like Wolfram Alpha to solve. Okay, so now that we know that we want our y prime to be in the form f of y times g of x so that we can divide by our f of y, let's solve a few example problems. So example problem 1, let's just say y prime is equal to 2t divided by 1 plus 2y. Okay, so I'll always write this as my f of y is going to be equal to 1 over 1 plus 2y. And then we have my g of t instead of x in this case is just equal to 2t. Okay, so now I'll write my dy in terms of dt, and then I will go 1 divided by f of y is equal to g of t, which then we can just multiply our dt over to the other side, and we get dy over f of y is equal to gt dt. Okay, so plugging this in, we get 1 plus 2y dy is just equal to 2t dt. Okay, now to get rid of the dy and dt, we can just slap an integral on both sides. So these are two pretty easy integrals, which is why I chose it for the first example. We just get y plus y squared plus a constant equals t squared plus another constant. Okay, so for this, I would actually get rid of my c by minusing on that side, And then I would just turn this into a C2, where C2 is equal to what I called C1 minus my other constant. And we can know if they're all constants, like 5 minus 6 is going to be another constant, which is -1. So we can always just combine those two constants to look like this. All right, so in this specific case, I see that I can solve for t a lot easier than I can solve for y. So I'd actually say t as a function of y equals plus or minus the square root of y squared plus y minus c2. Okay, so now we ask, well, how do we solve for this c2 constant right here? So this is actually found by initial values. So for instance, in this one, let's say that y, when t is equal to 2, is equal to 0. So we can just plug this in up here. So we have 2, which is equal to t, is equal to plus or minus square root of y squared. So y is equal to 0 right here. So we have 0 plus 0 minus c2. So then, solving for this, we can square both sides. So we get 4 is equal to minus c2, or c2 is equal to minus 4. So then we get our final equation, which is t is a function of y equals plus or minus square root y squared plus y minus minus 4. And this is what we call an initial value problem with when you get an actual solution, because you use this initial value right here in order to solve for our c in this general equation. Okay, so now for my last example, I'll be going over y prime equals negative 1 plus y squared over 1 plus t squared. Okay, so again, we can clearly see that this is separable by letting f of y be equal to, I'm going to say 1 plus y squared, and then I'm going to have my g of t equal -1 all over 1 plus t squared. Okay, so plugging this into our general equation that we got above, we get 1 over 1 plus y squared dy is equal to -1 over 1 plus t squared dt. All right, so now to get rid of our dy and dt, we do the same thing, slap an integral on each side, and then we look at that and we say, that looks kind of familiar. And then we think back to calculus 1 and we say, oh yeah, that is just arctangents. So we have arctan of y equals negative arctan of t, and we always have plus a constant when we are not given initial conditions. So then we have y as a function of t is equal to tangent of the negative arctangent of t plus a constant. Alright, so we can now solve for like an initial condition if we're given one. So let's just solve for the initial condition y of 0 equals -1. So that goes to -1 equals tan negative arctan of 0 plus constant. So what is arctangent of 0? So when is tangent of some value, let's call it x, equal to 0? So we know that this happens. We know that tangent equals sine over cosine. So either this has to be equal to 0 or this has to be equal to infinity. Clearly cosine of x doesn't ever go to infinity, so we know that sine of x must equal 0. So that goes to x is equal to 0. Okay, so that means that we know that arctangent of 0 is equal to 0. So let's get rid of that. So we have -1 tangent of my constant c. So now I have that my constant c is equal to arctan of -1. So now we ask, when is sine of x all over cosine of x equal to -1? So this would be sine of x must equal negative cosine of x. So now if we remember our unit circle, that's going to be right here. They're both positive. Right here, there's a positive and a negative, so I'm going to choose this point right here, which is 3 pi over 4. Okay, so now we know that c is equal to 3 pi over 4, which then gives us our specific solution, which is y of t is equal to tangent negative arctangent of t plus 3 pi over 4. And this is going to be our final solution for our original differential equation, which was given right here. Alright guys, so I hope you had a fun time in this video, or at least learned something if you didn't have fun. I will be going over a few more fun things in this series, so stay tuned. Remember to like, share, and subscribe, and I will see you on the next video in this series.